Welcome back to my YouTube channel, Massa Tutorials. Please do all to subscribe to this channel. Alright, we are still on Analytic Geometry and Calculus, Math 102. Alright, so we're on the subtopic relationship between the gradients of parallel lines. Relationship between the gradients of parallel lines. So let's start. Two or more lines are said to be parallel if they cannot converge at a point. Two or more lines are said to be parallel if they cannot what? Converge at a particular point or at a point. So if you have two or more lines, so let's assume if you have this line, let's say line 1, L1, then L2. So if these two lines converge at a particular point, let's say A, this is not the parallel line we are talking of. We are saying if two or more lines do not converge at a particular point. So if you have line L1, then line L2. Now, they have no meeting point. Then that means what? These two lines, L1 and what? L2 respectively, are said to be what? Parallel. They are said to be parallel. So, what we mean here is two or more lines are said to be parallel if they cannot converge. That means they cannot meet at what? At a particular point. So they move as that. So they move in a straight path. Then L1 the same thing, then what? L2 the same thing. So let's consider the diagram below. Let's consider the diagram below. Diagram below here. So we have our two-dimensional plane. So our origin, we have our y-axis, then our positive x-axis. Positive y-axis, then positive x-axis here. So let's assume that we have this line. Let's name it line AB. Line AB. Then another line. This is line CD. So now we have an angle here, theta. Then another angle here, theta. So we have two parallel lines. They are not meeting at a particular point. So they are said to be what? Parallel. So let's proceed. Line AB is said to be parallel to line what? CD. Again, line AB is said to be parallel to what? Line CD. Why? Because they make equal corresponding angles, theta, with the what? X-axis. Again, line AB is said to be parallel to what? Line CD. Why? Because we are saying that what? They make what? Equal corresponding angles with the what? With the x-axis. So they make equal corresponding angles with the what? X-axis. So this angle theta, let's say theta 1, then here theta 2. So theta 1 corresponds to what? Theta 2. Theta 1 corresponds to what? Theta 2. So I can say that theta 1 equals what? Theta 2. That's parallel lines. Let's proceed. Therefore, if vector AB, and we know what a vector is. A vector quantity or a vector is any quantity that has what? Both magnitude and what? Direction. A vector quantity or a vector is any quantity that has what? Both magnitude and what? The direction. The length, the modulus, the distance or magnitude. Then we know the direction, that's the bearing. Alright. So therefore, if this vector AB and what? Vector CD are said to have equal gradients are said to have what? Equal gradients. Now, in our last 2 videos, when we were treating gradients of a line, we said that if we have what? An upward slope, then that means we get what? A positive what? Gradient. So this one is an upward slope or an increasing function. So we have an upward slope. So this one, they have what? Positive what? Gradient. So this gradient is positive. Likewise, this line 2 has what? A positive gradient. So line AB has a positive gradient. Then line CD also has what? A positive what? Gradient. So what we are trying to say here is that therefore vector AB and vector CD are said to have what? Equal gradients. So to be precise here, we are saying that line AB or vector AB has what? A positive gradient. Likewise, vector CD also has what? A positive what? Gradient. So that's what we mean here. In general, if 2 or more lines have the same or equal gradients, they are said to be what? Parallel. In general, if 2 or more lines have the same or equal gradients, they are said to be what? Parallel. In general, if 2 or more lines have the same or equal gradients, they are said to be what? Parallel. So, in general, if 2 or more lines have the same or equal gradient, they are said to be what? Parallel. So, if this line AB has a gradient of 3, then that means since this line is parallel to what? Line CD, or since this line CD is parallel to what? Line AB, we are saying that what? They have equal gradients, the same gradients. Alright, so what we mean here is that if line 1, that's line L1, then L2, line L2 is parallel, then M1 equals what? M2. So L1 has a gradient, let's say M1, that's the gradient for L1. Then let's name here M2. Since they are parallel, we can equate their gradients and say that M1 must be equal to what? M2. That's what we mean here. So parallel lines have what? Equal gradients. Parallel lines have equal gradients. Parallel lines, they do have what? Equal gradients. Parallel lines do have equal gradients. So please watch it very carefully. So now, to proceed here, let's see. Notez bien. Let's do this quick note here. NB. NB. Notez bien. NB. To prove whether or not 2 lines are parallel, do the following. To prove whether or not 2 lines are parallel, do the following. So if you want to check whether 2 lines are parallel, we have to do the following. 1, we have to find the slope of each line. So find the slope or gradient of each line. Then 2, if the slopes are the same, the lines are parallel. If the slopes are the same, the lines are parallel. That's the symbol for parallel. If the slopes are the same, then the lines are parallel. 3, if the slopes are not the same, If the slopes are not the same, the lines are not parallel. So, if you want to check whether two or more lines are parallel, first of all, we do have what? To find the slope of each line. Each line we have to find for the slope. Then two, if the slopes are the same, the lines are what? Parallel. If the slopes are the same, we conclude that what? The lines are parallel. Three, if the slopes are not the same, the lines are not parallel. So here the key word here is not. If the slopes are not the same, the lines are not parallel. So kindly watch it very carefully. So now, we'll be solving examples here. We'll be solving examples and we know how best we can solve these questions. So examples. So we are starting with examples. So determine whether or not the following lines are parallel. So we have line L1, which is 2x plus 4y minus 3 must be equal to 0. Then line L2, we have 3x minus 6y plus 9 must be equal to 0. So determine whether or not the following lines are parallel. So let's determine whether or not the following lines are parallel. So watch the question very carefully. So now, solution. How can we determine whether the following lines are parallel? How can we determine whether the following lines are parallel? Now, we have the general equation. You can check L1 is in what? Is in the general equation form, right? 2x plus 4y minus 3 equals 0. So you have to change it to what? The slope equation form. So if I have 2x plus 4y minus 3 equals 0, then I have to send it to what? The slope equation form, which is the slope equation is in the form y equals mx plus what? C, right? So this one, I have to make y the subject here. So I have 4y equals, this one goes to the what? To the left, to the right hand side, sorry. So I have minus 2x, then plus 3. I want only y. So you have to divide both sides by the coefficient of y, which is what? 4. So I have 4y on 4, which must be equal to minus 2x on minus 2 on 4, then plus 3 on 4. So I have y, which must be equal to minus, this one here, 1 into 4, 2. So I have minus 1 on 2x, then plus 3/4. So for line L1, in a slope equation form, is in what? Y equals minus half x plus what? 3/4. Then now, let's see. L2, L2, which is 3x minus 6y plus 9 equals 0. So now, it must be in this form. Y equals mx plus c. So we have what? Minus 6y, which must be equal to minus 3x, then minus 9. Right. You have to divide both sides by the coefficient of y, which is what? Negative 6. So I have negative 6y on negative 6, which must be equal to negative 3x on negative 6, then minus 9 on negative 6. This one cancels, this one cancels, this one cancels, 3 here 1 into 6, 2. 3 here 3, 3 here 2. So I have y, which must be equal to half x plus negative cancels negative. So I'll get positive 3 on 2. So we can see that the intercept where this line cuts the y-axis is what? 3 on 4. Then this one where this line cuts the y-axis is what? 3 on 2. So I have it here. So this one is for line L2. Line L2. So line L2, then line L1. Let's compare. We have y equals minus half x plus the fourth. Then here y equals mx plus c. So we can see that m equals what? M equals minus half. M equals minus half. So we can guess if the gradient is negative, then that means this, it has what? A decreasing what? Function, or a downward what? Slope. That's it, a downward slope. A downward slope. Now let's see. We can get, here is M1, then here M2 is what? Half. M2 is half. So this one is a positive gradient. So it has what? An increasing function. That's what? An upward what? Slope. Now since here is negative, this one is positive. Since the gradients are not the same, then we conclude that they are not what? Parallel. Since their gradients are not the same, M1 is not equal to what? M2. So we conclude that what? They are not what? Parallel. So kindly watch it very carefully. All right, so let's move on. Let's move on. Let's move on. Alright, so next example. Determine whether or not the lines L1 and L2 So kindly pause the video, then try this question. Let me see. Alright, so let's go. So we have line L1, which is y equals 3x plus 2. So here we can determine the gradient straight away from here, which is m1, which is equal to 3 here. So the gradient here is 3, right? Then now here, let's see L2, which is 2y equals 6x minus 3. You have to divide both sides by the coefficient of y, which is 2. So I have 2y onto 6x onto minus 3 onto. So I have y, which is equal to 3x minus 3 onto. So we can say that m2 is also what? 3. So now here we can conclude that since m1 equals what? m2, indeed the two lines are what? Parallel. Since the lines L1 and L2 has what? They have gradients 3 then what? 3. We conclude that what? The two lines are what? Parallel. The two lines are parallel. So you can copy that. Alright, next question. Next question. Next question we have, if point A is 03, point B 72, point P 6 negative 1, and point Q negative 1 negative 2. Now we are asking, show whether or not line AB is parallel to line PQ. So if point A 03, point B 72, and point P, 6, -1, then we have point Q, -1, -2. Show whether or not line AB is parallel to what? Line what? PQ. So let's start with the solution. So we have this. So we can say that let the gradient of M1 be what? Line AB. So we have to find for the gradient of line AB. So I have the gradient AB. And we know the gradient formula, which is what? Y2 minus Y1 all on what? X2 minus what? X1. So X1, Y1, X2, Y2. So Y2, which is 2, minus Y1, which is 3, all on X2, which is 7, minus X1, which is 0. So I can proceed and say that the gradient of AB must be equal to 2 minus 3, which gives -1, all on what? 7 minus 0, which is 7. So I have a -1 on what? 7. Then I can say that let the gradient of N2 be what? Be line PQ. So if I have the gradient of PQ, which is equal to Y2 minus Y1, all on X2 minus X1. So I can proceed again and say that I have X1, Y1, X2, Y2. So Y2, which is -2, minus Y1, which is -1, all on X2, which is -1, minus X1, which is +6. So now, the gradient of PQ, which must be equal to -2 plus 1, all on -1 minus 6. So the gradient of PQ must be equal to -1 on -7. So here I have 1 on 7. Because negative cancels negative, so I'll get what? +1 on 7. Now here, since the gradient of AB is -1 on 7, and the slope will be what? The line will be what? Will be a decreasing function, a downward slope. Then here, since the gradient is positive, the line will be what? An increasing what? Function. So, since the gradient of AB is not equal to the gradient of PQ, we conclude that what? The two lines, that's line AB, then line what? PQ, are not parallel. Again, since the gradient of AB is not equal to the gradient of PQ, we conclude that what? Line AB is not parallel to what? Line PQ. So kindly watch it well. So I give you exercise, home link for you to go and try. Home link. I give you home link for you to go and try your hands on. So they are very, very simple. Very, very simple questions here. So home link. home link. Given that point Q, is 1 4, point R is 6 6, point S is 2 negative 1, and point T is 12 3. Show whether or not line QR is parallel to line ST. Then 2, determine whether or not L1 and L2 respective are parallel. So I have L1, which is so you try this home link. Alright, thank you for subscribing to Massa Tutorials. Until then, bye bye.